can we solve with considering the number of loops in the mechanism. So that is also possible. You are having the equation for solving this degree of freedom with number of loop. Like you can go with this degree of freedom is equal to n minus 2l plus 1, right, where n is your number of links, right, and this l is number of loops present in the mechanism. So here number of loop means, as you can see here, this one is the continuous fixed link, right? So if you see, you are having number of loop formed in this mechanism is this 1, 2 and 3, right? So this way, if you apply this equation, there will be the degree of freedom is equal to number of link is mentioned as 8, right, minus 2 into number of loops, that is 3, plus 1. So here 8 minus 6 plus 1, that is 7. So degree of freedom is 1 over here, right, for this particular mechanism. Similarly, if you go for this mechanism, you will have number of loop as 1, 2, 3, right, 4 and 5, right. So if you one second, I am admitting some of the students who were waiting, I guess. So one second. Yeah. So yes, here for the second question. Sorry. Yes.
Hello.
मेरे बोला ना, ये जो सर आप लाइव सेशन हमें पढ़ा दो सर, इनकी जो रिकॉर्डिंग है वो सर अवेलेबल होगी?
Actually, as I have asked you in the beginning, that first let me complete this session, right? So whatever your doubts and queries and requirements are there, that we will discuss at the end, right? Otherwise it will be difficult to cover whatever we have planned. Okay. Okay. So
Central question.
sorry. Hello.
Sir.
You are not clearly audible through. Hello. Hello.
Sir, I am telling where is the question of this answer.
Sorry, question.
सर ये जो आप आंसर टॉपिक पढ़ा रहे हो, इसके साथ पर्टिकुलर जो क्वेश्चन है,
हाँ,
वो किधर है?
See, I have asked you, or I have told you that we are finding the degree of freedom for this particular mechanism shown in these two different figures, right? So, have you listened to it or you haven't? Hello? Hello, Dhruv? Hello? Dhruv?
Hello sir, I have joined now only sir. Yes sir.
Huh. So what I have mentioned is.
Sir, I am audible now.
Sorry. Dhruv, we are finding degree of freedom for the mechanism shown on your slide. Is that okay for you now?
Yes sir.
Okay, let me continue please. Okay, so here in the second one, the number of loops are 5, so degree of freedom for the second one will be number of links minus 2l plus 1, right? So here number of link is mentioned as 12, right, minus 2 into number of loop is 5 plus 1. So here also your answer will be degree of freedom as 1. So this particular equation can be justified when you are having this kind of mechanism given. Otherwise you can simply calculate the number of links and number of binary joins and you can calculate the degree of freedom. So for that, your equation for degree of freedom is, as we have discussed, that 3 and minus 1. Kindly mute yourself everyone. Dhruv, kindly mute yourself. Yeah, so 3 and minus 1.
Sir, बस एक last question को
2j minus h. You can type in Dhruv. I will look into that. Please don't waste time, right, of so many people. Kindly type in. I will get back to you once I will complete some of the things I need to complete. Okay, thank you. Yeah, so here this degree of freedom is the 3n minus 1 minus 2j minus h minus number of redundant motion we are having, right? Number of redundant motion, mechanism is having, right? So this is also the equation which we have seen in the last lecture, right? So now this is how we have calculated degrees of freedom. Now let us move to the next topic, that is types of mechanisms. Now what is mechanism? As we have discussed, whenever we are having a kinematic chain and we are fixing one of the link of our kinematic chain, then we can consider it as a mechanism. So mainly basic types of mechanisms are this 4-bar chain mechanism, single slider crank chain mechanism, and double slider crank chain mechanism. So if we take the first one, then the first is this 4-bar chain mechanism. So 4-bar chain mechanism is having this 4 links, right, and all the turning pairs, right? This is link 1, that is fixed link. This is your link 2, 3 and 4, and all the link are joined with a turning pair. So here you are having 4 turning pair in your 4-bar chain mechanism, right? So now when you go for the next one, in your single slider crank chain mechanism, what you are having is, kindly mute yourself, everyone, please mute yourself. Right, so here in case of this single slider crank chain mechanism, you are having this fixed cylinder or fixed link. Inside that your slider will slide or oscillate. So you are having this link 1, 2, 3, and this slider is the 4th link. So this is how you are having your second mechanism, that is single slider crank chain mechanism. And in your third mechanism, you will have your 2 sliding pair and 2 turning pair. So here you can have your one of the slider which is connected to a slider over here, right? So you will have this 2 guideways, this guideways is one only, and this connecting rod will be the second link, and third and fourth will be your sliders, right? So this frame is your fixed link, right? And you will have this your very basic types of mechanism. Now inversion of mechanism. What is inversion of mechanism? Inversion of mechanism is whenever you will have the different links you are going to fix in order to get different.
Sir, please explain double slider crank chain mechanism again.
In double slider crank chain mechanism, actually, as I have told you, you will have 2 turning pair and 2 sliding pair, right? Generally this is used in elliptical trammel, right? So if you are going to see like this, yeah,
Third point, sir.
that is what the second means third point, this double slider crank chain mechanism. So in that, your particular point is going to travel an ellipse. If you take this point as x and y, and here you will have your both the sliders. So what is going to happen is, you can consider this as x distance, this distance as x, and this distance as y, and the angle made by this particular line is theta at both the places. I can actually even more elaborate view will be there. So this angle is theta at both the places, here as well as here, right? This angle is theta, this point is P, and let us say this as A and this as B. So this distance is x and this distance is y, right? This horizontal distance is x and vertical distance is y. So when you consider this cos theta, it will be what? X upon AP, will be cos theta in this particular triangle, let us say AOP. Similarly, if you take XB, or sorry, ZB, right? X is already we are using here. So if you take that AZB, not this one actually, this point here, PZB. So sine theta is equal to this y upon PB. So now if you take square and add them up, cos square theta plus sine square theta equal to 1, and cos and sine you can take x upon AP and y upon PB. So x upon AP square plus y upon PB square will be 1. This is nothing but equation of an ellipse. So this is generally used to traverse ellipse, right? So this is how double-sided crank chain mechanism is used. What I was telling is this inversion of mechanism. So inversion of mechanism is whenever you are having any mechanism and you are going to fix the different links of that mechanism in order to get different kind of work output as per your requirement, then that is considered as inversion of mechanism. Right now, so if we go to the different mechanism and their inversion, then here the first is this 4-bar chain mechanism. So in that you are having this different possible mechanisms when you fix different links, right? So the one is the first is this crank rocker mechanism, right? So if you see here in a crank rocker mechanism, what you can see is you can have this animation, I guess. Is that visible on your screen?
Yes, sir, it's visible.
So you can
Yes, sir.
so you can see this is crank and rocker mechanism, in which you are having your the smallest link having full revolution, and that output link is having that oscillatory motion. Output link is known as rocker, while the link having full rotation is known as crank. So when you fix the link adjacent to crank, you will have this kind of crank and rocker mechanism, right? So similarly, you can see this is used in your beam engine actually. Beam engine is one of the inversion of 4-bar chain mechanism. So if you see here on your screen, you can see now this is a beam engine. So here in this actually your mechanism is going to end at this particular point, right, where your this rocker is oscillating. After that, what you have provided this slider and cylinder is the other attachment you are attaching in order to get certain work done, right? But your mechanism is going to start with this crank, which is having full rotation, which is attached to this fixed link, and then this connecting rod, and this particular rocker which is having oscillation. So your actual mechanism is going to end at this point, but what this you are seeing is the attachment in order to get certain work done. So this is how you are having your crank and rocker mechanism, and it is utilized in your beam engines. Similarly, you can see on your screen double crank mechanism. So see, you are having a double crank mechanism. So when you can get double crank mechanism is when the shortest link is going to fixed. Here you can see on screen, this is the shortest link which is fixed, as you can see over here. So this is the shortest link which is fixed, and that is why you are getting this double double crank mechanism, because two links are having the full rotation, right? So where this particular mechanism is used is it is used in this coupling rod of locomotive, right? So if you see on your screen, you can see the coupling rod of locomotive, right? So here in this coupling rod of locomotive also, you will have two of your link is having the full rotation. So this is how you can have the second one's application. And the last one is double rocker mechanism. So double rocker mechanism is going to be achieved when opposite link of the crank is going to be fixed. Here crank is this one, the smallest link, or you can say it is going to be achieved when this opposite link of the smallest link is going to be fixed, right? So this green one is the smallest link and it is getting fixed, right? Sorry, this smallest link is this green one, and opposite to that particular link is fixed in order to get this double rocker mechanism. So again, let us see where this double rocker mechanism is applied, and you can see on your screen it is applicable in order to have straight line motion of your votes linkages, right? So uh, somebody has written nowadays there are no application of these inversions. I don't think so. Let us see, and that we will discuss at the end. So this is how you are having this straight line motion mechanism, right? Now the next is this single slider crank chain mechanism. So in that particular single slider crank chain mechanism, you will have your different four inversion: first inversion, second inversion, third inversion, and fourth inversion, right? So yes, as you can see on your screen, you are having this fixed link, then crank, which is having full rotation, then connecting rod, and then slider. So first inversion is link 1 is fixed, right? Link 2 is making the crank, and it is having the link 4 as slider. So this is your simple that single slider crank mechanism, right? So you can see that single slider, 1 second, it will be visible. I guess right now you can see this is single slider crank chain mechanism, right? After that, for second inversion, what you are doing is you are fixing the link 2, right? So which is crank. So link 3 is going to become the crank, and link 4 is anyway slider. So where it is used in Whitworth quick return mechanism, right? So this Whitworth quick return mechanism is used for having cutting operations and all, right? In your shaper and slaughter and all, you are having this Whitworth quick return motion mechanism, right? So this is how you can have your forward stroke and return stroke. Your forward stroke will take much time in comparison to your return stroke. You can, I guess, observe this is your forward stroke when it is going from right to left, which is taking more time in comparison to coming back, means from left to right. So this is how you are having this quick return mechanism, right? Similarly, this rotary engine is also using the same inversion. So here you can have your crank fixed, and you will get different what we can say different power stroke according to the rotation. Here 7 cylinders are there, and one crank is fixed, and according to that connecting rod is having this power stroke at different time, and this is how this rotary engine is working. So after that, inversion in the third inversion, your link 3 is going to fix. That is nothing but your connecting rod, right? So now what are you going to get with this one? That is crank and slaughter lever mechanism and oscillatory cylinder, right? We will see both one by one. So first is this one, crank and slotted lever mechanism. So here, as you are fixing your connecting rod, you will have this mechanism. It is taking time, I guess. It has come, yes. So here, this is your crank, this connecting rod you have fixed, and you are having your slotted lever, means inside that this a particular slider is sliding. So as you can see, this is how you will get your crank and slotted lever mechanism. Here also you will have cutting stroke and return stroke. So this we will see in detail. Also we will see some of the cutting ratio and this stroke length and all these things we will see in future, how we can calculate all those things. So after this you are having this oscillatory cylinder. So you can see on your screen you will have that oscillatory cylinder. right? Here you can see that you are having your cylinder is oscillating. Why here cylinder is oscillating and over there lever is also having that oscillations and all, inside which slider is there? Because your connecting rod is fixed and not your the last link which was previously used to fixed in case of the single slider crank chain mechanism. So this is how you have to observe these things, and you have to check at what particular inversion what are the links is getting fixed. So here in this bull engine you will have your that last link is fixed, that is link 4, right? So here you are having this bull engine, and one more thing is hand pump. So this is how you will have all your inversions for single slider crank chain mechanism, right? This is bull engine, and here you will have hand pump. It will take a while. So this is how you can have your different inversions for this particular single slider crank chain mechanism, right? So now if we go to the next one, that will be your double slider crank chain mechanism. And here in double slider crank chain mechanism, you will have the first one is this elliptical trammel, as I have shown you that particular equation, right? In that particular equation, as I have told you, that here you are having one particular point which is going to traverse an ellipse. So this is how you are having this double slider, and ellipse is being formed with that particular equation. Right, now next is this scotch yoke mechanism. So here in scotch yoke mechanism you will have that simple harmonic motion. As you can see, here you will have simple harmonic motion, and you will have here again two sliders, right? One is inside that particular slotted bar, and one is inside this cylinder. So this is how you are having this scotch yoke mechanism. And the last one is this old humps coupling, right? So you can have this old humps coupling. Here two slotted bar is there, right? At right angle you will have these slots, and you will have a connecting link which is having sliders which will going to slide inside these slots. So this is how you will have.
Hello.
Yes. Hello. Yes.
Yes, sir.
Huh?
Can you share problems related to degrees of freedom?
So degrees of freedom, that actually we will discuss last time, na? See, this whatever you are having doubts, we will discuss regarding the previous lecture or other things, huh? Right? Or whatever we are discussing today also, that also we will discuss. Okay, so here you are having this double slider crank chain mechanisms inversions. After that, some other important mechanisms are also there, like this Geneva mechanism and the ratchet mechanism. We will see that one by one. So here in Geneva mechanism you will have intermittent motion. As you can see, you are having that motion of that particular link which is colored in red are having intermittent motion. So this is how it is also called as this intermittent mechanism. And this particular this mechanism is used for indexing, right? So this is important while you are going to go for indexing and all. So this is how you are having this Geneva mechanism. And the last one is this ratchet mechanism. It is kind of self-locking, or we can say, see, this is self-locking mechanism, so it cannot come back by itself, that particular link which is having what we can say, uh, the one who is rotating in a particular direction. So the link which is having that halt at a particular place in that link cannot come back. So this is how it is self-stopping mechanism. So this is the ratchet mechanism. This kind of mechanism is there in watch and all. I guess it is utilized over there. So now, after having this different mechanisms, after looking at all these different mechanisms, let us see some of the important concepts which will help us in understanding or solving those conceptual questions in gate from previous year questions, right? So in that, the one of the important thing is Grashoff's law, right? So here if we see Grashoff's law, so Grashoff's law, what Grashoff's law suggests is continuous for continuous motion, right, in a mechanism for 4-bar chain, right? If you want a 4-bar chain mechanism to have continuous motion and one of them have continuous rotation, suppose this is crank, right, in your 4-bar chain mechanism, this is coupler, right, and this is your rocker, right? So if you want continuous motion of this crank or you want full revolution of this crank, then what is the required condition? So as you know, this crank is the shortest link, right, and if we are assuming this as the longest link, right, fixed link, right, longest link and shortest link, and this, let us say, length of this coupler is P and length of this rocker as Q. So what this Grashoff's law suggests, or it tells is, in order to have this continuous motion of your crank, the condition must be satisfied is the sum of shortest plus longest link should not be greater than the remaining two link. It means the sum of the shortest plus longest link must be less than or equal to
Sir, can you repeat again?
sorry, hello, hello,
Repeat again, Grashoff's law.
hello,
Sir, can you repeat again, Grashoff's law?
which law, hello,
Sir, Grashoff's law, ये वाली only.
that is what I am telling now.
Yes, sir.
Okay, so here, as I have told you, that Grashoff's law suggests that for continuous motion of in a mechanism of this 4-bar chain, in order to have your crank as continuous revolving motion, right, and you are having this completely constrained motion, what is needed is your length of this link, shortest link and longest link, have their sum less than or equal to the sum of the remaining two link P plus Q. That is what the Grashoff's law suggests. If in case this S plus L is greater than this P plus Q, right? So in this case, Grashoff's law is not satisfied. You will not have the crank and rocker mechanism or crank mechanism. The only remaining option will be rocker mechanism in case this Grashoff law is not being satisfied. So this is how you are having the importance of this Grashoff's law, right? So after that, if we see the second important thing, that is transmission angle. So one second, let me rub this for Grashoff's law and then I will write for the transmission angle. So for transmission angle, what is transmission angle first, that you have to have idea. So transmission angle is whenever you are having this your 4-bar chain mechanism, right, this is your crank, this is your connecting rod, and this will be your that rocker, right? So what is transmission angle? You are having this crank, this connecting rod or coupler, whatever you can say, and this is your rocker, right? So once you have this 4-bar chain mechanism, the angle between this particular connecting rod and rocker is known as transmission angle. This particular angle is known as transmission angle, right? This is known as transmission angle. Now if you see the optimum value of this transmission angle, then you can have this angle as theta, that as gamma, and you can have this length of link as A, B, C and D. Let us say this link length are given as this one, right? A, B, C and D. Now if you consider this diagonal as AB, right, or that particular distance as AB, and you say this as O1A, O2B, right, whatever, you can call this full mechanism as O1A, O2B. So if you consider that AB is there in both the triangles, and if you apply that cosine law in O1AB, if you are going to apply the cosine law, you will have that AB square is equal to A square plus B square minus 2AB cos theta. Right, similarly if you will apply this in O2AB, then you will get AB square is equal to C square plus D square minus 2CD cos theta. Now in order to get optimum value of the transmission angle D, that gamma, what you can do is you can differentiate this both with respect to theta. So if I take d gamma by d theta, right, if I want to find that d gamma by d theta, for that what can I do is I can equate this, because this is both nothing but this AB square only. So I can equate this, and as link A, B, C, D are constant, because these are link length, it is not going to vary. So A square plus B square or C square plus D square will be anyway 0, because these are constant. So what you are going to differentiate is minus 2AB minus sine theta d theta, right, equal to minus 2CD minus, here it is gamma because it is in O2AB, sorry, in O2AB this is gamma, so here this will be gamma, sorry, this will be gamma. So when you differentiate this one, second one, then you will have minus 2CD minus sine gamma d gamma, right? So now if you get that d gamma upon d theta from the above one, then it will be that AB upon CD, here sine theta upon sine gamma equals to 0. So it means sine theta must be equal to 0. So it means theta must be equal to 0 or 180 degree. Right, so in order to your gamma be optimum, your theta must be 0 or 180. So this is how you can calculate transmission angle and this importance of transmission angle in your 4-bar chain mechanism. So after this transmission angle, the next thing is MA. MA is nothing but mechanical advantage. So let us go through that mechanical advantage also. So all these things will be there, right? So if now we go for that mechanical advantage, right, that is MA, mechanical advantage. So for mechanical advantage, MA is nothing but your whatever F output, right, divided by your F input, right, or your power output, in other words you can say divided by your power input, right? So power is nothing but torque into omega, so you will have torque output, right, into omega output, divide by torque input into that omega input, right? So basically you can write that T output upon T input is also mechanical advantage, which can be calculated from omega input upon omega output. So your mechanical advantage can be written as T out upon T in is equal to omega in upon omega out. Right, so this is how you will have your mechanical advantage, right? And we will see for different types of mechanism how you can calculate this mechanical advantage, right? So now after this, yes,
So this is force output by force input.
yeah.
Okay.
So the next is this crank and slotted lever mechanism that we have seen. It is inversion or one of the inversion of single slider crank chain mechanism. Single slider crank chain mechanism, right? So here what is fixed is your connecting rod, right? As you can see, this connecting rod is fixed, and you will have a crank, right? So that crank is going to have full rotation as we have discussed earlier, right? So these are the position of your crank at which it will be perpendicular to this slotted lever. This is the slotted lever actually. Inside that this slider is rotating, right? And over here you can have one more link, right, in order to give your cutting stroke and return stroke. This may be ram, right? So R1 and R2, right? And here you can have this O, that B1 and B2. OB is your crank, right? And you can consider this as OP, that is your nothing but can say this connecting rod, right? So this crank will have full rotation, right? So here when your crank will have full rotation, here to here we will have that angle beta, which is nothing but cutting angle, because it is more, and as we have seen it will take some more time. Alpha is the return angle. This is alpha. That full will be alpha, that is nothing but return angle or return stroke, cutting stroke and return stroke related to this cutting angle and return angle. So now here let us say these are C1 and C2. According to B1 and B2 you will have your C1 and C2, right? So if you see here also you will have this particular perpendicular, let us say this as M. So here in your this single slider crank chain, your OB is crank, right? Your OP is connecting loop, then your this PC is slotted lever. PC is actually slotted lever. C1 C2 is your stroke length actually. C1 C2 is your stroke length.
अपन सी को पर्टिकुलर वर्ड क्या देंगे जो C1 C2 को हमारा स्ट्रोक लेंथ होगा
Sorry,
जो पर्टिकुलर वर्ड देंगे सी को
hello.
हाँ सर सी को पर्टिकुलर वर्ड क्या बोलेंगे जैसे हमने ओबी को जैसे पीसी को स्लॉटेड लीवर कह दिया ओपी को कनेक्टेड रोड कह दिया इस C1 C2 को हम पर्टिकुलर क्या बोलेंगे सर
तो वहाँ तो लिखा है, राइट नाउ आई हैव रिटन ना C1 C2 is stroke length.
अच्छा सर ये अच्छा
Okay,
यही बोलेंगे
okay,
ठीक है
okay,
ओके
okay, okay. Now here in this mechanism, some of the important terminology is this cutting ratio, right? Cutting ratio is beta by 1, right? And as you know, beta is always higher than alpha because beta is our cutting angle, and alpha is return angle. So beta by alpha is known as cutting ratio. Sometimes with the same name they may be provide you ratio as 1 is to 2, so at that time you need not to be confused and take beta by alpha as 1 is to 2. Right, in your question also if it is mentioned cutting ratio is 1 is to 2, it means alpha by beta is 1 is to 2, because cutting stroke cannot be less than this return stroke, right? So in general this cutting ratio is b by alpha, beta by alpha, or beta is cutting angle and alpha is that return angle, right? So this is how you are having this alpha by beta as 1 by 2. Now uh, as you can see uh, here, one more important thing to do is have idea about this stroke length, because this is of our interest, that how much will be the stroke length we are going to get if we are going to use it for a particular cutting operation or something like that, right? So now uh, hello.
Yes, sir. You are ready.
Okay, okay. So now, if we want to calculate this stroke length C1, C2, then it is actually symmetric. So if you take 2 into C1m, then also is equivalent to your stroke length. So if I write stroke length, right, stroke length, then it will be equal to 2 into C1m, because C1, C2 is nothing but 2 into C1m. Now, as this angle is alpha, this angle will be alpha by 2 in OB1 and P. In triangle OB1P, the angle B1OP is alpha by 2, right? So in OB1P, that angle B1OP is alpha by 2. So definitely this angle here, this angle, that is OPB1 or B1OP, will be 90 minus alpha by 2, right? So this angle B1PO will be 90 minus alpha by 2, right? So if you see here, then this here, this particular distance 2C1m is nothing but this 2 into this. If you take this triangle PC1M now, this one, you take this triangle now PC1M, right? Then in that you are having this 90 minus alpha by 2, and this PC1 is the length of slotted lever. So if you want to calculate this distance C1M, then this C1M is nothing but PC1 sine 90 minus alpha by 2, correct? So this C1M is PC1 sine 90 minus alpha by 2. So I am writing that C1 as PC1 sine 90 minus alpha by 2. Now it is 2 into PC1 into sine 90 minus alpha by 2 is nothing but cos alpha by 2. And cos alpha by 2 is what? If you see 2PC1 cos alpha by 2 in this particular triangle, now you will see this one OB1P, right, as we have taken. So in this triangle OB1P, what is this? Cos alpha by 2. So cos alpha by 2 is nothing but OB1 upon OP. So cos alpha by 2 is nothing but OB1 upon OP. So if you now observe the stroke length, then it will be made available from the different link length. Let us see in terms of that link length, how can you write that? So in terms of that link length, your stroke length is equal to 2 into PC1 is what? Length of slotted lever. length of slotted lever, right? What is OB1? OB1 is length of crank, length of crank. And what is OP? Length of connecting rod, right? So it will be in the denominator, length of connecting rod, right? So this is how you can have your this stroke length from length of different linkages in your this what we can say, crank and slotted lever mechanism, right? Length of lever, length of crank, and length of connecting rod will give you stroke length. So yes, hello.
Yes, sir.
Yes, sir. Completely visible.
Okay, so now I'm generating the poll, right, for this first I will generate for question number 8 of this K 2003, right? So I will write 8 and then 2003 in your poll. Let me generate that poll. So 1 second. So this question number 8 and 2003, right? So your option will be like A, B, then C and D. Okay. Now okay, can you see that poll now?
Yes, sir.
Okay, 1 second.
सर हो कैसे भी पोल सर
So
कैसे कर सकते हो सर एक
activities,
बार
you
बताओ
need to go to activities, then you will be able to see this polls. Activities. Hello.
So the pool is not visible.
Hello.
Yes, sir.
So all of you has answered for that question number 8.
Yes, sir.
So I didn't get the pool actually. From where I can see that?
You can see it from your this what we can say, activities. So I should end the poll or I should wait? Hmm.
You want to see the question again, sir?
One second.
Um,
Question number 8. Question number 8. You can answer for that one. Done? Okay, I'm ending the
yes.
poll now. Ending the poll. Okay, I'm ending the poll, and I guess. Can you see your results now? Can you see your results?
Yes, sir. Yes.
Okay,
Yes, sir.
okay. So
Where, sir, where?
in that activities
Result is
itself,
accurate.
I guess. So here, if you see the mechanism used is shaping mechanism, as we have just now seen that quick return mechanism is used for this cutting and return stroke, right? So inversion of the single slider crank chain is the mechanism used for this one, right? So many of you got the answer correctly, but still some of you have not
Sir,
scarlet.
you have,
Hello. Yes,
sir, result visible नहीं हो रहा सर.
I guess
Result visible नहीं है
I have already done this.
Shortest is longest
I have
one.
already made it visible to you. Okay.
हमें तो विजिबल नहीं है सर.
All others can see the result. Nitesh.
Yes, sir. We can.
Yes, the work is visible.
सर
Okay. So Dhruv, you
सर
can
कौन सा सर सही आंसर.
answer D is the correct one, as I have mentioned here. D is the correct answer. Now for
Sir,
the
I have a doubt, sir.
yes, please.
Sir, I am confused between the slotted lever mechanism and the quick return mechanism, sir. Is there a difference between them?
Actually, slotted lever mechanism is inversion of single slider crank chain mechanism.
Yes, sir.
Okay. So here, see why many of you have written this a closed 4-bar chain having 2 revolute or 2 sliding pair. Maybe because you have considered it as Whitworth quick return mechanism or something like that. Maybe. But
Yes, sir.
here it is
Yeah,
not
sir.
that clear. Here it is not that clear. They are talking about Whitworth quick return mechanism. But in the last option, they are telling that it is inversion of one of the single slider crank chain mechanism. That is why we are going with that option, which is more clear. Correct. I guess now I think you.
Yeah,
Are
now it's
okay.
clear, sir.
Yes. Sir. Go for the next one, and I am generating pool for that one. For the ninth question of this 2003, right? One second. Please mute yourself, everyone. Mute yourself. 9 2003. Your options will be E, B, C, D, right? One second. E, B, C, and D. So I will launch the question. Can you see it on your screen now, everyone? Right?
Yes, sir, it is visible.
Okay, now we can answer for that one. It is very simple, I guess. Quickly you can answer it, and I should end the poll. It will not take that time. Ben?
Hello, sir.
Yes.
Sir, actually, instead of coming from oldest to newest, can we go from newest question to the oldest previous year question, sir?
Actually, I will check this one for the next, we can say, session. But for
Sir,
now,
actually, in GATE 2022 session 1, there was a difficult question, sir, about that Grashoff chain MSQ question.
okay. At the end, if we will have time and all, then we can check that one, I guess.
Sir, sir, have you recorded this session, sir?
Sorry?
Actually, I am asking you that have you recorded this session? Like whenever we have some conceptual
Yeah, yeah.
problem, then we could recapitulate or rewind that video.
Yes, yes, yes. It is there. It is there.
Okay, sir.
Okay. And at
And at the end of the at the end of the session, it would be better if you could send us your mail ID that if we
yes, I will type my email ID in the chat box at the end, right? So
okay, thank
yeah,
you.
yeah. Yes. Hello.
Excuse me, sir.
Yes, yes.
Sir, can you kindly tell what are the important topics like which we have discussed, so that we can go through the topics once again, which are most
Yeah.
important.
Actually, till now, what we have seen important based on this gate point of view is the terminology used for the subject, like links, then kinematic pairs, type of kinematic pairs, then kinematic chain, mechanism, then mechanisms and their inversions, and then degree of freedom. And right now, what we are doing is we are actually checking or going through the questions based on the Grashoff's law and this quick return mechanism. And
Sir,
yes,
sir,
yes.
sir, this is your third session or fourth session?
Sorry.
Sir, this is your fourth session, fourth class or third class?
This is the second class.
Okay.
second class.
And sir, what about the recorded video of previous class so that I can watch and understand the questions?
Yes, yes, yes. That, as I have told you, it is already being discussed among the authorities. If they will decide, then it will be made available to you all. Okay.
Excuse me, sir.
Okay.
Yes.
Okay.
Yes. Yes.
Excuse
Yes.
Sir, can you share your notes or materials related to these topics and problems? It is helpful to sir to
Yeah,
practice.
yeah. All these things will be shared with you, but for that, a particular platform is being identified at this point of time. So whenever they will identify to where and how we can share this, we will definitely share this with you. Okay.
Through email ID can share.
Email ID I will write in the chat box. Second, you can note down this.
Sir,
One second.
sir, you can end the poll and represent the answer, please.
One second. I have mentioned my email ID in the chat box. Can you see that?
Once,
Can you see that?
Yes, sir. Yes, sir. Have got it. ME20D010.
Ah, yeah, yeah.
me, sir, I have it.
Yes.
Sir, double slide mechanism is important. Just like double slider mechanism is it important?
Sorry.
We discussed about the single slider crank, no, sir. Similarly, we also discussed about the double slider crank while you are doing the elliptical motion. Is that part also important?
Yeah, actually, see, you have to have a basic idea about all these things. Every time it cannot be asked, but it can be asked as some theoretical questions or something like that, right?
Okay.
Okay. So now, some of them is asking for some slides or display previous slides for two sessions. That we will see afterwards actually, right? Previous slide means which slide are you talking about? I am not sure. This one or what? Are you talking about this one?
Yes,
Hello?
sir. Last
Hello? Are you talking about this slide or what?
from the sir, the starting of the class.
Please mute yourself, everyone. Achyut, please mute yourself. Achyut. Okay. So now let us go to the questions. Right. Yeah. So for this I have generated poll. I need to end that poll. Okay, I am ending the poll. I have ended the poll and I have shared the result with you. Okay, so I guess you can see the result. Now we will see the answer. Many of you have given the correct answer that link length or a link of length p must be fixed in order to get this double crank mechanism, because we are we are fixing the smallest link, it is link p, right? So correct answer. Now let us go to the next one, that is this 2004. So I'm generating poll for that also. Please be quick now and please don't ask any other questions, right, regarding this videos or materials that we'll discuss at the end. Now we'll start with the questions, right? Please try to answer these questions. So this is 77 and P 2004, right? So options will be B, B, then C, and then D, right? I guess. So now you can have this question launched. 77. Right, 77 is launched, and kindly answer it as soon as possible. 30 seconds are enough, that is 30 to 40 seconds. Please be quick. Okay. Let us see how much you have answered. Please be quick. 5 more seconds and I will end. 5 more seconds. Okay, I am ending this one, right? Okay.
Hello.
Yes.
Sir, I want to ask one thing that the practice set questions that have been mentioned in the website, this website,
Uh-huh.
and one test is already completed. So
Yes.
those tests are only previous year questions or new questions are there?
Actually, I'm not sure whether from how which database they are generating these questions and all that. So I have no idea whether it will be all from previous year or they are having some new set of questions or something like
Okay,
that. Okay.
okay, sir.
Okay. Okay.
Actually, sir, last one I missed. I'll see in the next test.
Okay. Okay.
Sir, and also solve that test paper questions, sir.
I am solving sir, I am seeing the solution of one question from 2011 heat transfer. Question number third. There is no full solution of this question, sir.
Okay, okay. We will discuss all this at the end, I guess, because right now we are at the important phase of this lecture, and that is to solve these questions, right? So let us focus on solving these questions first, and then we'll discuss these peripheral
Okay, sir.
things. Okay, okay. So here the answer C is correct because Ford-Russell mechanism is this straight line mechanism. Geneva mechanism is intermittent mechanism. Then this offset slider crank mechanism will be this quick return mechanism, and Spokes-Yoke mechanism is simple harmonic mechanism. Right. Now I'm generating it for that eighth one. So please be quick again here also. Right. So now for that I am generating this is question number 8, right? Question number 8, and that is 2004. Question 8 of 2004, and again your these options will be A, B, C, D. Right. One second. Okay, so I'm launching this question. Yes, I guess it is visible to you all. Now please attempt this one. Yes. Please look at the question and attempt it. I guess by now you must have answered the questions. Let me go to the polls. Okay, so I'm ending the poll. Okay, so you can see the poll. Many of you got it correct. Here, what they have asked is mechanical advantage. Right, so as we discussed here, mechanical advantage will be equal to the T output upon T input is equal to that omega input upon omega output. What is omega input over here? This will be omega input over here, right? Because here you are having this kind of mechanism, right? Like this and this. And here you are having this slider. Like here this configuration is
What is
like this.
what is input by you?
Sorry, omega omega
So
output.
work input by work output.
So here,
Omega?
please mute
It is
yourself.
omega, sir. Omega.
Yes, this omega is there, omega input upon omega output. This we have derived already, right? So here omega input will be having certain value of omega, but omega output is 0 because your slider is having this linear motion. So omega output is 0, and that is why this infinity is the correct answer for this mechanical advantage, right? So now let us go to the,
Sir,
yes,
sir, I want to ask, sir, in the slide you wrote mechanical advantage as power output बटे power input. So, sir,
yes, yes.
then, sir, वो तो equal होंगे ना, power output और input.
Yes. Actually, it was not correct. I guess that is my mistake. From there, I guess force and torque only can be given in that particular equation. Yeah, here it
Okay.
is torque only. Let me modify it also. Thank you. One second. I'm modifying this one. It is torque only. Sorry for that. Right, it is torque only. So torque output or force output and torque input can be considered for this mechanical advantage calculation. Okay, thank you. So here after this one, let us go for the next one, that is 2006 question. Here again toggle position, right, will have this one second, let me first draw you this mechanism. This is the overbar mechanism, right? Here what you can do is you can extend this particular link, that is connecting road, right? And here you can have this angle as beta, or this angle as whatever gamma what we have written, right? And you can draw a perpendicular from both of this particular point, right? So you can call it as AB, sorry, what's ABCD, right? So here A, B, C and D. So you can take that A, B dash and D, C dash, right, as this what you can say perpendicular to this line is PA, D. Sorry, to this line PC. Right, from A and D you can have that perpendiculars. So now here what they are asking is to calculate the mechanical advantage in toggle position. So what is toggle position is, here you can have this A to B, and again then B to C will be there only, and then you can have this particular position A, B, C and D. So here this particular position is known as toggle mechanism or toggle position for 4-bar chain mechanism. Right. Now in order to calculate the general mechanical advantage, first we can write that mechanical advantage is nothing but, as we have discussed, this T output upon T input to omega input upon omega output, right? So now here this omega can be considered as this r omega, is what you can say, omega is v is equal to r omega. From that you can have that what you can say r by sorry, omega is equal to r by v, or we can have that omega is the distance into theta. So based on that, this rpd upon rpa, this from instantaneous center method, I guess they have taken. We will discuss instantaneous center method in detail, right? So here this rpd upon rpa, this is the distance pd over here, and there is the distance pa over here. So omega in upon omega out will be equal to this rpd upon rpa. Now rpd upon rpd can be calculated from similar triangle. rpd upon rpa can be calculated from the triangle like r c dash d upon r b dash a, r c dash d upon r b dash a, right? So why? Because p b dash a and p c dash d are similar triangle, right? So from this you can have this r c dash d is nothing but r c d sine gamma, and r b dash a is nothing but r b a sine beta, r b a sine beta. So now this is the equation for mechanical advantage actually for you now, right, for this mechanism. And as you can see here, what is happening is this particular beta is becoming 0 or 180, you can say, in the toggle position. So if this beta is going to become 0 or 180, then we will have again the answer as infinity. So here also your answer infinity is the correct for this mechanical advantage.
सर लास्ट वाला पॉइंट दोबारा बताना सर, ये आर सी डी साइन गामा बाई आर बी ए साइन बीटा के बाद।
हाँ, इसके बाद see what you have to do is you have to calculate your mechanical advantage in toggle position where this beta, right, this beta actually becoming here 0 or 180, you can say beta is becoming 0 degree. That is why this sine 0 is 0, right? And as sine 0 is 0, your mechanical advantage is nothing but that r c d sine gamma upon 0. Anything upon 0 will be infinity only. So for this also you will have your this mechanical advantage as infinity, right?
Sir, what is this R?
R is that link length, I guess.
Okay.
Right. Here this RPD is distance between PD, RP is distance between P and A. So RCD, RPA will be the length of links. Okay. So
So what toggle position?
sorry.
So toggle position.
Toggle position as I have drawn here. No? This is toggle position, where our link AB and BC are in the same line. That is toggle position for 4-bar chain mechanism.
Okay, sir.
Huh. So now here number of inversion for slider crank mechanism, as we have seen, it is 4 because we are fixing each link one by one and we are having that inversions. So from this 2006, these two questions are there, so which is clear almost, right? Now for this one, again one this question is there, but this is also, I guess, easy. Do you want to try and answer in 4, or should I directly tell you? What do you say?
Tell us
So directly I can tell you that this higher pair means you are having this line contact, right? So here when you are having a higher pair, it means line contact. When you are having lower pair, means surface contact. For a quick return mechanism, it must be this shaper, right, as you have seen, and mobility of linkage is related to this Grubler's equation, right? So Grubler's equation is also related to this degree of freedom equation, because as we have written this 3n minus 1 minus 2j minus h minus this redundant motion, right?
Grubler's equation is that?
Grubler's equation is whenever you are having degree of freedom is 1 and your what you can say your number of higher pair is 0, at that time you can have your Grubler's equation from this equation. This is known as actually Kurzbach criterion. This is Kurzbach's criterion.
Sir, कौन सा?
And when you
In notes.
please mute yourself. So here
सर आपने ये क्या लिखा है सर? KN T.
Kurzbach's criterion, right? It is
सर
Kurzbach's criterion, right?
back.
Okay.
और सर ये ग्रबलस इक्वेशन ये जो ऊपर है सर
Grubler's
3n
equation is
माइनस
this one. When you consider degree of freedom as 1 and higher pair as 0 and no redundant motion, then you
ओके
can have this 3n minus 3 minus 2b minus 1 is equal to 0, right? So this is, I guess, this 3n minus 2 minus 4 is equal to 0. This way you can have your Grubler's equation, which will give you idea about the mobility, right? So the next one is this. It is also simple. In Grashoff's law, what is the condition for Grashoff's law? Can anyone tell answer for this one?
Yes, sir.
सर ये सर s plus n less than equal to p plus q.
So correct answer is A, right?
Yes sir.
Okay, okay. Now let us go for the next question.
Be wrong, sir.
Sorry,
Be wrong answer.
sorry.
B answer is wrong, sir.
A answer is the correct answer. Na? I have marked A only, na?
सर इससे पहले वाले का क्या था आंसर आंसर बी था ना सर उसका
इसके पहले वाले का आंसर C है. Whatever we have calculated, this is C.
सी
हाँ, P6Q2 R5 and then S. Sorry.
ओके
हाँ. Okay.
नहीं
S1.
नहीं ये सर डी है इसका
Yes, yes, yes. Sorry.
डी है
Yes, yes, yes. Okay. Okay. Okay.
ओके
Okay. Right. So after this, yes, this one is done. This one now, yes. Now can you try this one? I should generate poll for this, right? I'm generating it 82 only, right? 83 I will discuss.
length of the crime kill hammer
Yes. 1 second. Let me generate poll.
cool.
One second. One second. It is question number 82, right? In 2007. Question number 82 in 2007. 1 second. A, B, C, and D. Last. Yes. Can you see the code? Please try this.
Wait sir wait
Question number 82. Please try this.
yes sir so there one by two alpha by beta length of the crime kill hammer
Please mute yourself.
500
Dhruv, please mute.
500
Dhruv,
Okay.
please. Okay. So have you answered this?
sir
So should I end or what?
and
Okay. So you can see your results. Okay. So let us try and see what actually here is. So here this is connecting road given as this OP, right? P, and this may be the extreme positions, right? Okay, this may be the OS crank, right? And this like this. Now, what is given is alpha by beta. Is you see alpha by beta is given as 1 is to 2. So as you can see here, this full angle is alpha, right, and this angle is beta. So this beta is nothing but 360 minus alpha, equal to 1 by 2. Right. So here we will have 2 alpha is equal to 360 minus alpha. So we can have this 3 alpha is equal to 360, means your alpha is equal to 120, and your alpha is equal to your beta will be 250. Now if you see this whole angle is alpha, so this angle is alpha by 2, right? So if you see this OS, then because there is a OT. So what you are asked is length of the crank, right? Length of the crank means this OT or OS is the length of the crank. So
Excuse me, sir.
yes.
Sir, your voice is not loud, sir. I can't hear.
Okay. Can you hear me now?
Ah, yes, sir.
Okay. So here the crank is OS or OT, and this angle is alpha by 2. So if you take this particular triangle OTP, right, this one, so in that your cos alpha by 2 is equal to OT upon OP, right? Now cos alpha by 2 means cos 60 is equal to OT upon OP. OP you know, right? OP is given as 500, and OT is nothing but your crank length. So OT is equal to this 500 cos 60. Cos 60 is nothing but 1 by 2. So your correct answer OT is 250 mm, right? So this is how your this.
So the crank is OS, no sir?
These are the different position of crank, OT or OS, as we have seen while the derivation of those equations, right? So here also it will be same. This angle is also alpha by 2. So if you go for this particular triangle, then also cos alpha by 2 will be equal to OS upon OP.
Okay, got it, sir.
Got it? It will be same only, correct?
Yes, sir. Yes.
Okay. Now the next thing asked is to find the angular speed of PQ. So omega PQ you need to calculate, right, when this R is going to attain the maximum speed. So R is going to attain the maximum speed when these two links are at perpendicular to each other, right? So in that case, what is going to happen is your linear velocity will be same, right? So linear velocity is nothing but this distance into omega, right? So OS into omega s will be equal to this particular distance PQ into omega PQ, right? Now here what you are asked is angular speed of PQ, that is this omega PQ you are asked, right? Because omega OS is given as 2 revolution per second, right? So here omega OS is 2. OS means length of that crank, which is already calculated as 250. So here if you put all the values 250 into this revolutionary speed 2, here PQ is not mentioned, but I guess 750 they must have provided or something like that. So 750 is that length of this slotted bar, and then omega PQ. So if you solve this, then you can have your answer as 2 by 3, right? So this is how you will have this particular questions regarding this quick return mechanism, right? And one more question is like similar to that is there, right? Like this one. Oh, I guess it got crashed. I need to again open that. One second. Give me 1 second.
So can
One
we
second.
continue tomorrow? No, next week.
It will take me 5 more minutes. Let me come complete this one. It will take me 5 more minutes. 1 second, 1 second.
Okay.
Once, yeah, it is there. Yes. So again, I'm presenting the screen. You can see them. Right, 1 second. Yes. So can you see my screen now? Can you see?
Yes, sir.
So this is very similar question that we have done right now, right? So here this quick return mechanism ratio is given as this 2 is to 1. So beta upon alpha is 2 is to 1. So again you will find alpha as 120 and beta as 240, right? And here what you are asked is the distance, 1 second, O1P is provided here, right? So you are asked to find the distance between the crank center to lever pivot center, that is this D is asked, right? So if you go and put the equation same cos alpha by 2, then it was equal to that O1P upon O1 O2, right? So again here cos alpha by 2 is cos 60, that is 1 by 2. O1P is given as 125 and O1 O2 is your distance D. So your D will be again here 250 mm. Right, so it is very similar to what previously we have solved. So question 12 will be this 250 mm only, right?
In the previous question, R attains maximum speed
When that particular angle between this RQ and PQ is 90 degree. At that particular point it will attain the maximum speed. Sorry? Hello?
No, sir, nothing,
So that
nothing.
will be 90 degree.
Sorry?
So the angle between PQ and RQ will be 90 degree or 180 degree maximum velocity at R.
90 degree, na? It will be 90 degree. Right? So, still I will check. You can also check, right? We'll see that. Okay. For now, let us see. This also we have solved. After that, this one. This is again a very simple question. Continuous relative motion. So here, can anyone try this one? Continuous relative motion we have seen just now. Which law states for continuous relative motion? Anyone?
Grashoff law.
Okay, so this will be here. Then velocity and acceleration. That you
Kennedy.
Yeah.
DLM.
नहीं सर, Kennedy और mobility Gilbert criterion,
Mobility
dynamic
and dynamic analysis.
dynamic status
DLM. Right, so correct. So
Sir,
P
sir, may you please help us in recalling Kennedy's theorem?
actually that we will discuss at length when we will see instantaneous center method, right? Instantaneous center cannot lie on the same line, right? We will see that Kennedy's theorem in detail when we will see the relative velocity method. Okay.
Okay, sir. Thank you, sir.
Okay, so here this P3 is only this option, so this B is correct, right? Because P, continuous relative motion, is Grashoff's law, right? And this is the last one. Let us see the last one. So this is also very simple. Which of the following statement is incorrect? Can anyone answer? Anyone of you?
A.
A is the incorrect statement. Correct. Correct. Okay, so now what you can do is, now I'm stopping this screen presentations.